Good morning, everyone. I will be presenting my research titled The Effect of Foot Strike on Injury Location in Runners. My name is Isabela. I'm a student at Carmel High School. My mentor is Dr. Nelly Galindo, a doctor and physical therapist at Outreach Physical, Occupational, and Speech Therapy in New York City. Who runs or knows someone who does? I do. In fact, I'm not alone. Us runners join the 65 million in the United States. And already we're facing a frightening statistic. As many as 90% of us are expected to get an injury and miss training time every year because of this. With a statistic like this, it's no wonder that runners are constantly searching for ways to prevent injuries. And many are looking at foot strike, which is the way you land, as a factor to prevent injuries. So like I said, foot strike is the initial position of your foot when it hits the ground. It can be divided into 3 different anatomical divisions. You have the phalanges, which is like your toes, the metatarsals, which is like the area, the foot pad right underneath your toes, and the tarsals, which is like the heel. So why did I decide to look at foot strike? Because there's actually many factors that affect injuries. There's stride rate, training, footwear, foot strike, and impact forces. So what's interesting is that it's already known increasing your stride rate can help you minimize your injury risk. When you're training, you can avoid overusing the same areas of the body, allowing your body to recover. That will also minimize injury risk. With footwear, if you adopt footwear with less support and cushioning, that will help you prevent injuries. And with impact forces, the lower your average load rates, or the lower your average impact forces, the less likely you are to get injuries. So the last 3, footwear, foot strike, and impact forces, have an interesting connection that persuaded me to look into foot strike alone. So I'll show you how footwear changes your foot strike, and based on different foot strikes, you have different impact forces. So as far as footwear goes, there's 2 different extremes. Having a support with high cushioning, high support, like the Hoka One shoe in that picture, or having barefoot, which is like no support, no cushioning, or minimalistic shoes, which kind of mimic the barefoot gait. These are my shoes. So based on the different footwear you use, it changes your foot strike. When runners have high cushion, high support shoes, they tend to adopt a tarsal strike, so that's the area of your heel. Whereas runners who run barefoot have a metatarsal and phalange strike. And so how does this affect your impact force? Well, they did Davis in 2015 did a study looking at the impact forces in the 3 different strike groups: rear foot strike, metatarsal strike, and the phalange strike. You can see the black line is actually the tarsal strike, and you can see there's an impact vertical force that's absent in the other strikes. And so what does this play out to you? It impacts those runners with twice the rate of repetitive stress injuries in rear foot than forefoot strikers. So that's an insane disadvantage if you're running with tarsal strike. And despite this research, most running shoe companies will still market the high support, high cushion shoes, which you might see in a store or own if you're so summing it all up, there are known methods of injury prevention. 1 is less footwear support with a transitional period to properly strengthen the muscles in your foot. 2 is increasing your stride rate. And 3 is adopting a phalange or metatarsal strike. But with this known, there's still a gap of knowledge. Which is the better strike, phalange or metatarsal? So in order to answer this question and really figure out once and for all what's the best foot strike to run with, I'm going to compare the injury location distributions across the strike groups, and at the same time answer the question, does running foot strike affect the location of injuries? So in a refined question, this is how do injury location patterns differ between the metatarsal, phalanges, and tarsal strikes? So taking this refined question, I have the null hypothesis that there will not be a difference between the foot strike groups, so they will have the same injury risk. And then the alternative hypothesis is that one foot strike group, for example, the phalanges group, will have a higher injury risk than the tarsal group in one area of the body. So with 8 different areas of the body examined and 3 different strikes, there are a total of 32 alternate hypotheses tested. So in order to answer this question, I decided to use a survey, and it was completely anonymous. I actually had 2 different locations where I distributed my survey, in New York and in Bogota, Colombia, which is the capital of Colombia, and then a Google form was available online for those above 18. So if you were under 18, you would have to have consent by your parent or guardian. The mentor verified that the Spanish translation of the survey was correct and validated most of the procedures in the research to ensure that they were scientifically accurate. So the study itself, the survey itself only took 10 minutes to complete, and once I had the participants complete it, I got some demographics. First of all, there were 43 runners who took my survey, and they were between 15 to 30 years of age, which is expected because I distributed my surveys at running camps and schools, so they were around that age. The weekly running mileage of the participants was an average of 30 miles per week. The gender, 22 female, 19 male, and 2 did not respond. So looking at one of the most important questions from my survey, I asked the participant, using the foot, your running shoe that you've used the most in the past 6 months, where's the area of most wear on your the sole of your shoe? So if a participant selected 1 or 2, they were placed into the phalange strike group. If they selected 3 or 4, that foot pad area, they were placed into the metatarsals group. 5 or 6 would be phalanges. So this question really determined what their foot strike group would be. The second most important part of the survey was asking them for their injury history in those same past 6 months. So I also controlled for if participants had congenital abnormalities, such as having one foot that's shorter than the other, or anything like that that could possibly increase their susceptibility to injuries, despite outside of the variable exam. So none were reported in the study, and the 8 different injury locations were the knee, lower leg, foot, upper leg, toes, hip, ankle, back, and other. So with these 2 things, their injury history and their foot strike group, I could then proceed to statistical analysis. So I compared the injury location distributions across the foot strike groups. I had 32 one-tailed 2 proportion z-tests. I used 2 proportion z-tests because I was comparing proportions of runners who had injuries over the total and across the different strike groups, and I used a TID4 plus calculator. The sample was random, independent, and normal, which verified that I could proceed with statistical analysis. And the alpha, as used in previous literature, was 0.05 for each test. So out of the 32, first I'll show you a result of the survey. So I actually asked the participants for their general perception of what did they think was the best foot strike to run with, just based on what they thought. I expected that most participants would perceive heel strike to be the best foot strike to run with, because again, the running shoe companies really are marketing those highly cushioned shoes which facilitate heel striking. But on the contrary, actually 56% perceived the forefoot strike to be the best foot strike to run with, and only 9% perceived the heel. So this is actually where the wear on the sole of their shoe is located, and this is what their foot strike group is. So there was 65%, the majority of runners were in the forefoot strike group, and 35% had wear on the sole, on the heel. So looking at the descriptive analysis, this is kind of the 8 different locations on the x-axis you can see, and then the 3 different strike groups are pink rear foot, green phalanges, blue metatarsal. So I wanted to look at if these differences in injury risk across the different groups were statistically significant. So for example, I would compare the phalanges injury risk in the knee to the metatarsals injury risk in the knee and see if that was a statistically significant difference between them. So this is actually the same test, and I'm looking, I called it the best foot strike determined because with this test, I really determined which of the 2 metatarsals or phalanges was the best foot strike to run with. So I compared injury risk in the knee, like I mentioned before, in phalange metatarsal strikers. The p-value is 0.04, which is statistically significant at the 5% level, because it's less than alpha, it's statistically significant, it's enough evidence to reject the null hypothesis, and therefore it can be concluded that injury risk in the knee will be lower for metatarsal strikers than phalange strikers. So this really does determine the best foot strike because they have a lower injury risk. They are the better foot strike to run with. So the second statistically significant test, because I did 32 total tests and 2 of them were statistical. So this is the second one, contradictory toes. You'll understand why it's contradictory in a second. So basically I compared the injury risk for the rear foot, which is like the heel, and the phalange strikers. The p-value is 0.03. And it was less than alpha, so it's statistically significant, again at the 5% level. And so it's enough evidence to reject the null hypothesis, and therefore it can be concluded injury risk in the toes will be higher for the heel strikers than the phalange strikers, which are the toe strikers. So this was a little bit contradictory because I expected that since the phalange strikers land on their toes, they would have a higher injury risk for the actual toes, but that was not the case. So they have actually less of an injury risk. And so that kind of goes against the location with the most impact force ID because like that's what the toes is what has direct contact, so I expected it to be the higher, but it wasn't the case. So possible reasons for why that might be is that when you land rear foot and slap down on your toes, like you go like this and then you slap down on the toes, perhaps you're actually putting more stress when you rebound and like go off the ground. Second reason could be that the body actually has adapted sensory feedback mechanisms to minimize injury risk despite an increased impact force. So the toes will actually widen when you continually walk barefoot or run barefoot. Your toes will become more flexible and wider. So limitations, honesty of participants, discomforts and diagnosed injuries were counted equally, and the area of most were to be misidentified. So in conclusion, injury location patterns do differ based on foot strike. There is a lower injury risk for metatarsal strikers than phalangeal strikers in the knee, and this essentially means that metatarsal striking is the best foot strike to run with to avoid injury. It's an injury prevention tool. And secondly, because I thought this was interesting because the majority of participants perceived it to be the best, and a majority had that strike, which was the one that I concluded would be the best foot strike. So it kind of concurred with what the people had. The second finding, again, injury risk for the rear foot strikers would be higher than in the phalange area. It supports this current research that heel striking is detrimental, and it really does push companies to inform consumers and market more minimalistic shoes. The study raises question on how feedback mechanisms could minimize injury risk despite having a large loading force applied on that area of the body, and of course, how do loading forces change with different running strikes? Future studies could use a larger sample size, review ideal stride length, and look at what are the best minimalistic shoes for running efficiency. I'd like to thank everyone who helped me with this project. Here are my citations, and if you guys have any comments, questions, or concerns, they're welcome. And this is kind of like a bubble to reinforce the main points that were brought from this research. Metatarsal striking can help avoid injuries, and companies should rethink the shoes they are marketing because most of us have never really seen these in stores. So, the toe shoes. Thank you.